Imagine you're working for an online retail company, trying to predict whether a visitor will make a purchase or just leave the site. It's not about how much they'll spend, it's whether they'll buy at all. That's where logistic regression comes in. It's a statistical method designed to handle outcomes that are binary: yes, no, true, false, 1, 0. Logistic regression is all about probabilities. It helps us predict the likelihood of an event happening, like whether a patient has a disease based on symptoms or whether a loan applicant will default based on their credit history. The beauty of this method is that it models the relationship between a binary dependent variable, like purchase, no purchase, and one or more independent variables, like browsing time, cart size, or past buying behavior. Logistic regression is a superstar in binary classification tasks. Let's break it down. Medical diagnoses. Imagine predicting whether a patient has diabetes based on factors like weight, blood pressure, and glucose levels. It's either yes, they do, or no, they don't. A perfect fit for logistic regression. Credit scoring. Financial institutions use logistic regression to decide if an applicant is likely to default on a loan. A combination of income, credit score, and existing debt can predict whether someone is a high-risk or low-risk borrower. Marketing campaigns. Picture this. You're running an ad campaign and you want to predict whether someone who clicked the ad will make a purchase. Logistic regression takes in data like age, location, and interaction history to give you the odds. What makes this model tick is the logistic function, a mathematical twist that converts predictions into probabilities between 0 and 1. If the probability is closer to 1, the model leans toward a yes. If closer to 0, it's a no. Before you unleash logistic regression, certain conditions need to hold true. Binary dependent variable. The outcome must be categorical, no decimals, no in-betweens. Think of it as flipping a coin. Heads or tails, no, it landed on the edge. Independent observations. Each data point must be unique and unaffected by others. If the outcomes influence each other, like multiple predictions for a single customer, logistic regression might give you a flawed output. Linear relationship in the logit. Here's the technical part. Logistic regression doesn't assume a linear relationship between your variables outright, but it assumes that the logit, the log odds of the probability, has a linear relationship with the predictors. This might sound complicated, but it's what makes the model flexible yet accurate. No multicollinearity. Independent variables should not be highly correlated. Otherwise, your model can struggle to understand which variable is actually influencing the outcome. In essence, logistic regression turns complexity into clarity. It's like a decision-making compass, guiding you through the fog of uncertainty. Whether you're a marketer, a doctor, or a data scientist, this model helps answer one of the most important questions: will it happen or not? But as powerful as it is, logistic regression is just one tool in the regression toolbox. There's a world beyond binary outcomes. And up next, we'll explore how regression models can handle nonlinear relationships.